Hi students. In this video we're dealing with a word problem about a ball that's thrown into the air. So it's going to rise into the air and it'll slow down eventually and then it'll start falling. The formula, the function that represents the height of the ball, is given by h of t equals negative 16t squared plus 100t. And it's probably a good idea to take note of what each of the various pieces of this function means. So first of all, t represents time, but another way to think of it is this is our x value. We're obviously calling it t, not x, but in the purpose of this function, it's the value that we're plugging in. And then h is basically our y value. So another way to think of this function, at least if we wanted to think of it graphically, we could think of y equals negative 16x squared plus 100x. This is a degree 2 function, or its biggest exponent is a 2. So that means it's going to be in the shape of a parabola. And we can learn a lot of things about a parabola just by looking at the function itself. For instance, if it starts out with a negative number, it's going to be a concave down parabola. That means it's going to have a maximum point. So some of these questions have to do with things like that. So let's look at the first part of this question. It says the ball reaches a height of 75 feet after what times? Don't let some of this notation with T1 and T2 confuse you. It just means we're going to have two answers, a first answer and a second answer. So if they say a ball reaches a height of 75, they're asking us to put 75 in for h. The height is 75. So we would rewrite 75 equals negative 16t squared plus 100t, and we want to figure out what time that happens, so solve for t. The easiest way to solve for t is to get 0 on one side, so I'm going to subtract 75 from both sides of my equation, which would be 0 equals negative 16t squared plus 100t minus 75. And then we need to solve for t using one of two methods. We can either complete the square, or we can use the quadratic formula. Here, I think the quadratic formula will be a little bit easier since these numbers are pretty big and completing the square would be a challenge. So let's use the quadratic formula. Our a is negative 16, our b is 100, and our c is negative 75. We're going to plug all of that in. I almost wrote x equals. It should be t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that'll be negative 100 plus or minus the square root of 100 squared minus 4 times negative 16 times negative 75. Now this is a lot of stuff, so I'm going to pause my video for just a second and do some of these calculations off screen. This is just arithmetic. You can plug this into a calculator, so there's probably no need for me to work this out step by step. Okay, so I did some calculations here. First I simplified the discriminant, which is what's inside the square root. Then I simplified it down a little bit more, and you end up with this really ugly answer. This would be the most simplified fractional form we could put it into, but since we're talking about a practical, real-world problem, we actually want to use decimal numbers as our answers. So one more time, we're going to use our calculator and we're going to plug this in, and we're going to get two different answers. We'll have our first t value and our second t value, and these will just be based on the plus versus the minus sign here for our answer. Okay, when I plug both of those in, I end up with 0.87 seconds and 5.38 seconds. The instructions were really clear that they wanted you to put the smaller number first, so we'd put 0.87 as our T1 and 5.38 as our T2. Now, visually, I want to explain what's happening here. We already talked about how this function is represented by a downward-facing parabola. The question they posed was, at what point will the ball reach 75 feet? So if this is 75 feet right here, our ball is going to reach 75 feet at two different times. First at 0.87 seconds, and then again later at the 5.38 second mark when it's on its way back down. So that's why we ended up with two answers there. All right, let's move on to the next part of the question. The next part asks, does the ball reach a height of 125 feet? Yes or no? Well, the key to answering this question is to figure out what our maximum is. If our maximum, say, is, 200 feet, then certainly at some point it's going to pass past the 125 feet mark. If our maximum is, say, 100 feet, then no, it would never reach the 125 foot mark. So for this second question, let's just find our maximum. The x value of your maximum, or in this case, the t value of your maximum, is equal to negative b over 2a. It's a little vertex formula that we learned. Well, we already know what a, b, and c are, so negative b would be negative 100, and a is negative 16. So plug this into a calculator. Positive 100 over positive 32, which is 25 over 8. Let me just quickly type that in to a calculator. You end up with 3.125. So our maximum value occurs at the time of 3.125 seconds, but the h value at the maximum would be h of 3.125. So let's actually plug that into our function now. Negative 16t squared plus 100t. Pull out a calculator. And you end up with 156.25. So the maximum height our ball is going to reach is at 156-ish, 156.25. And that happens at the time of 3.125 seconds. So our maximum height is 156. That means that we definitely will reach a height of 125 at some point. So this is a clear yes. The next question asks us to find the maximum height and the time at which that height is achieved. Well, we just answered that question. So our maximum height is 156.25 feet, and that occurs at time 3.125 seconds. Oh, they already have seconds here. Finally, they want to know when the ball hits the ground. We are looking for the moment when the height would be 0. That's when the ball hits the ground. So we're looking for this point right here. This is the moment when the ball leaves the ground, so we don't want that one. We want the moment when the ball hits the ground, which would be the further right point. So that's going to happen if h of t equals negative 16t squared plus 100t. The moment when the ball hits the ground will be the moment when the height is 0. So we're going to put 0 in for h of t. That'll be negative 16t squared plus 100t, and we need to solve for t. So the easiest way to solve for t in this example is by factoring. So on the right-hand side, I'm going to factor a t out into the front, leaving me with negative 16t plus 100. Now that it's factored, I can set each factor equal to 0. T equals 0, and negative 16t plus 100 equals 0. And to solve for t on the equation on the right here, I'm going to subtract 100 from both sides. And then I'm going to divide both sides by negative 16, which gives me 6.25 seconds. So notice we ended up with two answers. This first one, t equals 0 seconds, represents when the ball left the ground. The second one, t equals 6.25 seconds, represents the moment when the ball comes back down. So that would be our answer here.